Let's solve question 9 now. We're going to use implicit differentiation. So, question 9. We have a function where we have y cubed equals to 13 minus 3x squared times y. And we want to know the derivative of y in the point of 2 and 1. So what is the whole thing about implicit differentiation? The idea is that the function depends on both x and y. So the function literally depends on x, on the independent variable, and on itself, on the dependent variable. So how would we proceed here? Well, we will take the derivative of both sides. And when we take the derivative of both sides, we take them with respect to x. Literally, the word implicit, it means that x is implied in our y. So let's see how it all makes sense. Don't get confused by too much terminology. So derivatives, and we're differentiating with respect to x. X is our variable of interest. We're differentiating with respect to it. What is y cubed derivative? Well, by using the power rule, that's just 3y squared. But remember, y is not our variable of interest. Y is a function of x, so we're using the chain rule. We're differentiating the function itself, so multiplied with y derivative equals to 13 derivative. Well, a constant derivative is just 0, so that's 0 minus, what do we have here? 3x squared times y derivative. We're going to use the product rule, so let's just write 3x squared times y derivative. We're going to differentiate it in the next step. Let's keep moving. So we have 3y squared times y derivative equals to minus, and now let's use the product rule. This will be our first term, 3x squared, and y will be our second term. So we would have 3x squared derivative, 3x squared derivative times y plus 3x squared times y derivative. Okay, let's move on. We have now 3y times y derivative, 3y squared times y derivative equals to minus, and here we have 3x squared derivative, that's just 6x times y plus 3x squared times y derivative. Okay, we got that. Let's open the brackets. Let's just open the brackets. So we have 3y squared times y derivative equals to minus 6xy, and then the negative sign from here, it affects the positive sign and it converts it into a minus. So minus 3x squared times y derivative. Okay, we got that. Now we have y derivative and y derivative on both sides, and what do we want? We want to find out the value of y derivative. So let's bring them together. Let's bring these terms together. Let's take it to the other side, meaning that we will have 3y squared y derivative plus 3x squared times y derivative equals to minus 6xy. 6xy. Let's take some space. What do we have now? We have a common factor. We have y derivative as a common factor, a common term. Y derivative, y derivative. So we have y derivative, and here we have 3y squared plus 3x squared equals to minus 6xy. So we have y derivative equals to minus 6xy divided by 3y squared plus 3x squared. 3x squared. What can we do still? We could take 3 as a common factor, so we can cancel something out. We would have minus 6xy divided by 3 times x squared plus y squared, and let's actually cancel it out. 6 and 3 goes away, so we were left with minus 2, and that would equal to minus 2xy divided by x squared plus y squared. The question was, what is y derivative at the point of 2 and 1? Well, that's equal to just minus 2 times, instead of x we plug in 2, so times 2, and instead of y we plug in 1, times 1, divided by x squared, that's 2 squared plus y squared, that's just 1 squared, So the result would equal to just -4/5. And that is the final answer. We're done.